Hey guys, we just wrapped up class and we had some problems on number 3, so I'm going to go over it briefly and hopefully this makes some sense to you. Just to refresh you on the situation, we have the bike cop moving at 7 meters per second, the thief is at 2.5 meters per second, and we want to figure out what angle the thief or the bike cop should take in order to collide with the thief here. So the two are still 60 meters apart, and we want to figure out what this angle is here. So I redrew this over here, and I labeled this distance that the thief travels as L, and the distance that the bike cop travels as X. So I have that situation set up, and what I did first was I related the velocity of my thief as 2.5 meters per second to L and time. So 2.5 equals L over T, and then I did the same for the bike cop. So 7 meters per second as the bike cop's velocity is equal to the distance the bike cop travels as X over time. So here it is. I have those two expressions, and then I just rearranged them in terms of L and X. The next thing I did was I looked at the triangle and I picked out the sine of the angle as L over X. So sine of my angle here is equal to opposite over hypotenuse. Sine is L over X, and I rearranged that for L. So here I took the expressions I had for L, the expressions I had for X, and I substituted them in. So for X, I have 7t. For L, I have 2.5t, and the time should be the same. Can you guys work through that logically? The time that it takes for the thief to get to this point should be the same amount of time that it takes for the bike cop to get to this point, which is why we say they are colliding. The times are the same, so they can cancel out in that expression. So all you have left is sine of theta is equal to 2.5 over 7. If you throw the 7 on the other side. You do the arc sine of that, and you should get a theta of 20.9. You can double check that, and it looks right on our picture. That is the bike cop and thief problem. Hope this made sense.